All right, this for section 4.5, rational functions in their graphs. All right, this is covering my open math material. So now when we're looking at this, right, we're talking about rational functions. Rational functions are fractions. That's what they are. So there's domain restrictions and such things. It's like you can't divide by 0. So you're going to have a concept of these things called asymptotes now. You have vertical and as well as guided horizontal asymptotes. I say that for a reason, but now when we're looking at fractions, right? So let's take a look at this. We have fractions. Now, in order to put it in your graphic calculator, you have to get used to alpha y equals enter, and it'll give you a fraction. Okay, I mean, so really get in touch with the concept of the fraction. It's alpha y equals enter, and it'll give you fractions. If you're using the current updated operating system, I personally prefer this particular calculator myself. That's what I've been using. So anyway, we have 1 over x. That is the basic function. You also have alpha y equals enter 1 over x squared. That one's common as well. So we enter that one. Okay. So now if we graph those two, there's the first one, and there's the second one. All right. They are following this concept of vertical asymptote. Now, if you go ahead and second graph, you can see where if you entered 0 in for x, it would be an error for both of them because you can't divide by 0. All right, so that's why that is. And then the horizontal asymptote won't be discovered or revealed. Okay, so just to let you know, you have to kind of know a little bit about horizontal asymptotes in order to find them. And so I'm going to go over some of those properties for you, okay, for this particular lesson. So consider the following graph. Determine the equation of the horizontal asymptote of the graph of f. Now, the equation of the horizontal asymptote, the equations are always going to be y equals. Okay, always starts out with y equals. And then the equation, if the horizontal line falls with a dashed line like this, where does that indicate? And all you're going to do is look on the y-axis, and it's on 2. So the horizontal asymptote is y equals 2. And that's your answer. All right, it's that simple. There's no real big deal about it. Now determine the equation of the vertical asymptote. Now the vertical asymptote is going to be always x equals. And that's going to be where it falls on the x-axis. So that would be -4. All right, and there's your answer for that one. This is really simple. I mean, really just look at the dashed lines and where they fall on each respective axis. Determine the domain. Now, domain is restricted based off of the vertical asymptote. So if the vertical asymptote is at -4, the domain in interval notation will be from -infinity all the way up to -4, and then jump over that -4. We've talked about how to write interval notation before. So there's our answer. All right, and then the range is going to be where you're looking from top to bottom, and that's going to be same thing. It's going to be where it's -infinity all the way up to our horizontal asymptote. And then we're going to jump over that. Okay. All right. So we have that. Okay. Pretty straightforward. And so this one right here is that 1x squared business. Okay, it's the one, but it's inverted, so it would have a negative in front of it. So the equation might look something like this. All right, the equation probably looks something like that because it moved to the right, moved to the left 4 units, so that's why it's positive 4. And it moved down 4 units, and then it's been inverted or reflected. I should say reflected, not inverted, but reflected over the x-axis. Okay, so, but anyway, not that you need to worry about that. But the horizontal asymptote obviously is going to be y equals -4. And then the vertical, or that's the horizontal, the vertical asymptote's actually the same exact thing, but it's x equals, and then the domain and the range. Okay, here we have it. Pretty simple. All right. Now you have the equation. It says find the domain. The domain is going to be all real numbers except for where you have a 0 in the denominator. That's as simple as it is. So then x cannot equal 7 here. So in interval notation, you write it the way I wrote this one over here. Okay, this right here is the same thing, except rather than having a -4 or a +2, it'd be where it's 7. Okay, domains are really easy. This one can't equal 4, and its interval notation is going to be the same thing as this one, except for it's going to be with a 4. Because you're always jumping over the where its denominator equals 0. All right, that value. Now this one, two numbers that multiply together to create 63 that adds up to 16 negative would be 9 and 7, right? So the two answers are negative, so they're going to be positive. So it's going to be 9 and 7 is your values of x. So we can't have either one of those. So we go ahead and throw that out. Okay, so we jump over it. So how you do that? Again, just go like this. All right. So we have our answer. Pretty fast. These aren't challenging. Last lesson was harder than this one. Okay, this is just understanding some concepts that are a little different. But you have set bill notation. I'll let you guys factor the denominator and put it in interval notation. Okay. I've done enough of these already, so I'm going to continue to go on. All right. Finding the domain of this, of course, it's -13 and +8. All right. Pretty simple. You're doing it with both of them. This one, there is no domain restriction on this one. So domain is all real numbers. Whereas with this one, it's going to be, there is going to be, well, I don't like it written that way. Personally, I'd write it this way. It's just why? Because it's like x cannot equal 3 or -3. I should say plus or negative. All right. Plus or -3, because you got a difference of 2 squares. You should see that immediately when I'm looking at that. Okay. I mean, if you can't, and you don't know about your factoring. All right. You should have seen this as this. I always worry about students, like their skill sets coming into college algebra are not where they need to be at times. So you should see that you're jumping over. That's why you got this. All right, you're jumping over -3 and then jumping over +3. Okay. And then the equation of vertical asymptote, it's going to be where x cannot equal 13. So the vertical asymptote, it says the equation of the vertical asymptote is just going to be x equals 13. And the x value where the graph of k has a hole, okay, there is no hole on this one. All right, now I'll explain what a hole means in just a minute, but there is no hole in this one. It does not exist. A hole forms when you go through a process. All right, let's just say hypothetically I had this, for example. We know that this factors out to be this, right? And we already know that there's a hole, or excuse me, there's an asymptote at these two values. Well, what happens when you knock one of them out? All right, is that you clean it up and say, well, now the vertical asymptote is only at -3, not a +3. So what happens is a hole forms at that point where something got knocked off. All right, and that's kind of going to happen in the next couple problems you'll see, and you can see it on your graphing calculator. Okay, here in number 10 is an example of one, because you're going to knock out the x, because you're going to factor out an x, right? And I'm going to factor out -x, because when I factor out -x, I'm going to get this. All right, and then the x's knock each other out. But at 0, at the value of 0, there's a problem, right? Because you can't divide by 0. So we consider that discontinuity point. So we have to recognize that as a hole, and that's what you're going to see here. X, where the graph has a hole, is at x equals 0. All right, and that's where we have to throw it out. And interestingly enough, it's going to appear on your graphing calculator as well. Watch what happens. Let's go back to here and clear all this junk out. Let me punch it in the graphing calculator and show you some stuff. All right, now so alpha y equals fraction, then I have 13x over 2x minus x squared. And then we go ahead and graph it. All right, so we knew at the value of 2, right, there was going to be a vertical asymptote, and that's showing here. It's clearly showing. All right, but when you look at this right here, and you got to look at it very closely. Let me see how looks like a blank spot right there. Look like the graph didn't get completely filled. It's because they know that that's a discontinuity point or a hole. And you can find that by hitting second graph and going to 0 and seeing that it's an error. Even though it's, not a vertical asymptote, it's still an error. And if you go to the value of +2, and you'll see also an error. All right, because that's our vertical asymptote. So that is what we talk about when it comes down to when things are getting knocked out. Okay, very clearly seen on the graphing calculator as well. All right, and the vertical asymptote is going to be at x equals 2. We discussed that already. So we're looking at a lot of different properties, right? Here you're going to have that situation I gave you here. This is the same exact thing, but it's going to be with the -7 rather than -3. All right, so we're going to have a hole at the value of 7, and then of course x equals -7 is a vertical asymptote. Can't emphasize enough how if you put this into the graphing calculator, how it's going to yield these values as well, because you can look for it as far as errors are concerned. But it doesn't dismiss you from understanding the concept of simplifying things, okay? I mean, you got to learn how to do that. Now, it gets a little bit weird when you're looking at such things as this. This gets more and more complicated. But all they're saying is determine the equation of the horizontal asymptote, if any, of the function below. Now I'm going to have a discussion about heard of, how to find horizontal asymptotes. This one's looks like it's a wild equation, but we're not focused on much of it. All we're focusing on is the horizontal asymptote. Now let's just give A and B, okay, is a rational function. Now we call this M and N the degree powers for these variables, okay? But actually, what we need to make sure is that the variables are the same. So we're going to go ahead and do this, okay? And then we have some arbitrary, I'll just say P and Q. All right, so we have constants here. We don't care about them. The constants don't matter. It's the variable. And we can call out the variable x because you're used to it, right? You're used to saying it's x. I call it a because it doesn't matter what variable it is. But we talk about this, but all we're really focused in on is these two numbers. All right. And it has to be in descending order. You have to have the equation in proper descending order. Okay. So when we're thinking about this equation, what is the value of the x that's multiplying against the constant? It's 0. All right. And this one's 1. And any time you have where the degree power of this is less than the degree power of the bottom by 1, right? I like doing that. Okay. It doesn't necessarily have to be by 1. Yeah, it's just as long as this one's greater or less than this one. Then it's y equals 0. Okay. Y equals 0 is your horizontal asymptote. So that means when m is less than n, then you have this. All right. Now, if it's where they're equal to one another, so you have, for example, 4x to the second, and then it's 3x to the second. They're equal to each other. Then that means that you take, and that's why you have this, is that this results the value of the leading coefficients as a fraction. I want to say a little. It doesn't matter. It's this number right here. So in this example, it would be 4 over 3. And so it is the leading coefficients that become a ratio. It's the ratio of the leading coefficients. So it becomes a fraction. So that would be the horizontal asymptote for when they are equal. Now, when m is greater than n, so in other words, we have 5x to the 5th, and then we have x to the 3rd. When this is greater than this, there is no horizontal asymptote. D&E does not exist. All right. So now when we look at this one right here, all right, we have x to the 4th, and then we have x to the 2nd. This is higher than this, so therefore it's no horizontal asymptote. All right, it's really actually an easy thing to do once you understand all this, right? And you remember it. It's not hard to get. So we look at this. All right, we see that this is x to the 2nd. This is x to the 4th. This is less than this, so it's going to be y equals 0. Okay. So anytime that the m is less than n, then y equals 0. Okay. And then, oops, looks like these are exactly the same. So it's going to be the ratio of -4 over 2, which reduces down to just simply y equals -2. The horizontal asymptote is always going to be y equals. Remember that, okay? So, I wish if there was any questions, you had any, you can let me know, but this is pretty straightforward concept. So determine the horizontal asymptote. This is 3, this is 2, this is greater than this, does not exist. All right, no horizontal asymptote. Pretty simple. Now, matching the function. This is where you use your graphing calculator. But the thing is that this is a graph of a rational function that moved 2 units to the right and 5 units up. So 2 units right then becomes our vertical asymptote, and then 5 units up becomes our horizontal asymptote. And it looks like this one is the answer, right? I mean, it's exactly where it is. So that's what we give. All right. So we go ahead and submit that as our answer. Okay. Well, anyway, can't seem to find where it gives me the answer. All right. I don't know where the answer block is, like the key. But anyway, now you're matching them. And I would encourage you at this point to get comfortable with putting things into the graphing calculator. But doesn't dismiss you, again, from knowing the basic structures. This is moving 5 units to the left, 3 units up. This is being inverted over the, I say inverted like it's such a thing, but it's being reflected. That's the word I'm looking for. That's the other R word I'm looking for. Reflected over the x-axis, being moved to the right 1 unit and being moved up 2 units. So you can go ahead and match that up to what you're expected. All right. So that's not that complicated. And the same thing goes for this. You got to remember the basic constructs of how things are reflected over the x-axis, moved up and down, and then moved left and right. Okay. And knowing the basic constructs of like this, the idea that we have, and I showed it to you in a graph, but we have it where this is x squared. This is the basic parent function. And then you have the 1 that looks like this, where this is the basic constructs of 1 over x. Now, take note that this goes through 1, 1 and -1, -1. All right. This one goes through -1, 1. This one goes through 1, 1. All right. Just so you can get that into your head, okay? And you can see that if you just graph the parent functions again on your graphing calculator, okay? It's not like that's alarming or you couldn't figure that out. It's called observation and just knowing that you have your trusted calculator that can give you that to you. All right. And take, when you do it, all right, go in there, and when you're punching it in, all right, it doesn't hurt to go ahead and look at the output values. Okay, so I'll just do it again, 1 over x, and then you hit graph. That's what that looks like. But maybe you can't see where those points are, so you can go over here and see, what does it look like at -1? -1 is -1. At 1, it's 1. And that remains consistent for the parent function all the time. No matter, even if it does get translated, it will still hold to the same exact properties of that -1, -1, 1, 1, but it'd be in its respective location based off the horizontal and vertical asymptote. Okay, so those are the things you just kind of pay attention to. All right. I like those conversations because they're really important for the student to experience. So using the reciprocal function 1 over x, which is obviously our parent function, determine the rational function in each graph below. So this one is the parent function, but remember the parent function is supposed to look like that. This is being reversed. All right. So this is, it's the opposite. So that means it must have been reflected over the x-axis. All right. along with that, it's been moved, the horizontal asymptote is -3 along with the vertical asymptote of 1. So you use that concept of the negative sign because it's been reflected, and then the -1 is the vertical asymptote is 1, and then because it's been moved to the right 1 unit, and then it's been moved down 3 units. And so you use that concept throughout all these, okay? And you get the idea about how to construct these equations, all right? Now, analyze the graph of this. Now, you start putting all these things together. You start talking about the domain, the vertical asymptote, all these different components. Now, when you're doing such things, I would say the first concept or the first process you want to get used to is putting it in your graphing calculator. All right, just so you can get a visual picture of it. Some students have a harder time with visual, picture. Now, the next thing is that I go ahead and start cleaning things up. I don't like, I'm going to factor out -4 from this, and I'm going to get x plus 4. All right, and then I have an x here, and then I could reduce that down to 1 over -2. I could even actually put the 2 up to the top, but it doesn't still deprive us of the fact that we have vertical asymptote. So vertical asymptote is at x equals -4. All right. And then I still have a horizontal asymptote. And the horizontal asymptote is going to be right here. You can see that they're the same. So the horizontal asymptote is where y equals, and then we could go ahead and just take the leading coefficients, and that's going to be -1/2. Hey, it looks like it was drawn out when we did the simplification of this. Okay, but anyway, we don't see the variable x, so that doesn't stand true. You don't want to just assume that. So always do the horizontal asymptote. All right, the domain then is going to be all real numbers except for where x equals -4. All right, so that's the answer for that. So determine the domain, and you write an interval notation all the time. List the equations of the vertical asymptote. Kind of already did that with you already, right there. All right, and the horizontal asymptote. All right. Oh, yeah, there's no holes that exist. I didn't simplify anything or wipe out any variables. Okay, so, oh, and by the way, there's still an x up there, and I didn't put the x up there. All right. I was like, where did the x go? Anyway, my B. All right, now, determine the equation of the horizontal asymptote. All right, we've already determined that. All right. X-intercept. X-intercept is where y equals 0. So you go ahead and set that equal to 0. And the thing is that you can also use your graphic calculator to determine that. All right. For the sake of this, it's 0, 0. Okay. Now determine the y-intercept. It's going to be the same exact answer when it's 0, 0. And then choose any 4 additional x values. Now you can choose anything you want. X values need to be entered. All right, and that's true for all these answers, and then you get the resulting value for whatever you produce. Okay, if you enter a value in here, then this will create the output needed for it. And all you got to do is, when you're doing it, is use your second graph gives you your table, and you can use that too. Okay, and then sketch the graph. This would be where you then determine what graph it is. All right, and you can look for that, just by seeing it on the graph, or the graphic calculator. All right, but you can also get the properties based off of here. I mean, you can determine it pretty quickly. Okay. All right, well, then you do that over and over again. all right, you go ahead and determine all these different value systems based off of those parameters. So a lot of this is just using your graphing calculator, doing comparisons and simplifying and like looking really at where you stand regarding your properties. All right. So I'm going to leave you at that. I'm going to let you have that. There's repeated values structures, and it allows you to have that experience. Okay. So I want to cut this one short a little bit so you can have that experience and be able to determine it. Okay. So good luck with this lesson. It's not that hard.